We have frame forwarding decisions down cold. We know everything that's going on. So now we got to talk about another set of questions going on inside the switch, I should say. And that's how the frame will actually be processed before this forwarding decision is made. And the thing is, you're going to see this is not nearly as involved as frame forwarding because your switch is not going to continually go back and forth from one processing method to another. It's going to have a default. It's not something you're going to change. Most Cisco switches today that I've seen use store and forward, but I'm not saying you'll never see cut through and fragment free either, although apparently I'm starting to use double negatives. I'll stop that. However, for our test, we've got to know all three of these processing methods inside and out. There really isn't a whole lot to know, but we do have some important clarifications and lines to draw between them. Because as with everything in life and networking, each of them has a particular benefit and each one has a particular drawback. And with store and forward, this is, I think, the most common processing method out there today. And it sounds exactly like what you would think any frame processing method would do. Because first, the entire frame is stored by the switch before transmission or forwarding begins. And you think, okay, well, that makes sense. I would expect that. Well, also with store and forward, the switch analyzes that frame check sequence field, the FCS field, to see if any data corruption occurred while the frame was being transmitted. Again, we like that because since the switch stores the entire frame before beginning to forward it, the switch can check the FCS before the forwarding process begins. So the switch can find out if there's a problem with that frame before it begins to forward it. And again, you would look at this and think, okay, that sounds exactly what I think frame processing should be like, right? Well, this allows the greatest level of error detection of the three methods we're going to look at here. And we also like that. We'll take all the error detection we can get. This level of error detection also means that store and forward processing is the slowest method of the three. Now, we're going to go to the other end of the spectrum here with cut-through switching. Because what happens here is the switch actually begins to forward the frame before the entire frame has even been received. So, we're basically saying, here's your hat, what's your hurry? Well, that's not just low error detection, that's zero error detection. There's absolutely no error detection with cut-through switching. The silver lining, if there is one, is that cut-through switching is the fastest of the three methods. But that's a pretty high price to pay for faster speed, is just having absolutely no error detection at all. So you're thinking, I sure hope that third one is a middle ground, and it is. Fragment-free processing. What's happening with fragment-free is that the switch makes an assumption which is pretty safe in that if there's going to be corruption in the frame, it's going to be in the first 64 bytes of the frame. That is the only part of the frame that fragment-free processing examines for corruption. And if it doesn't find any corruption in the first 64 bytes, it says, okay, you're good, go ahead, pass, and the forwarding process begins. And as far as speed goes, fragment-free is faster than store and forward, but slower than cut-through. Makes sense. So that's your frame processing. Those are your three frame processing methods. I would know which one's fast, which one's slow, which one gives you the best error detection, which one gives you the least, and which one is the middle ground in both of those areas. Now, we've seen MAC addresses, we've talked about them, but we really haven't examined closely where we're getting this address from. Because it is, pardon this term, a pretty funky looking address. It looks got some zeros and some letters in there and a couple of dots. What the heck is this thing? Well, we're going to have a word here about the two parts of a MAC address. And this is a MAC address that came directly off one of the live Cisco switches that we're going to use in our labs. The first half of that address, 001C0F, is the organizationally unique identifier. Unfortunately, we pronounce that OUI, the acronym. I wish we said we, but we don't. It's OUI, and that's exactly what it does. The organization that it's identifying is the vendor, and each OUI is assigned to one and only one vendor. And as you would expect, a company as large as Cisco has many OUIs. And you can go online and see a list of these for not just Cisco, but Netgear, or just about any other large company, or even some small ones. And you'll see their OUIs. So you can actually look at a device at some point and say, or a card, and look at the MAC address and say, okay, I know what vendor made this. It's not something you have to do on the test, but you got to know what that OUI is all about. So if that's the first half of the address, it follows that we need to talk about the second half of the address. And that was BF2F04 in this particular case. And this is a combination of hex characters not used by this vendor on any other device with this particular OUI. So it guarantees that this MAC address is unique to that vendor. So again, that first half, that's your OUI, your organizationally unique identifier, and your second half is just a combination of hex characters not yet used by that vendor on any other device with the same OUI. There are several different ways to express a MAC address, and I say it that way because this falls under the category of, this is one of those things I wish someone had told me when I was studying for the CCNA. Because you'll read different books, you'll see Cisco documents as you go through your studies and your career, and sometimes you're going to see MAC addresses where the 12 characters are separated by 2 periods. Then you'll see them separated by 5 dashes. Then you'll see them separated by 5 periods. And then other places you'll see them separated by 5 colons. These are all acceptable ways to express the same address on paper. Okay? The thing is, you're not going to be able to put a MAC address in on a Cisco switch when a command calls for it. You're not going to be able to put it in any way that you want to. What you'll do is use iOS help to see exactly what the format is, and then you'll enter it in whatever they give you. When we get to the port security section, you will see exactly what I'm talking about, because frankly, you could go a long time without actually typing in a MAC address on a Cisco switch. It's not something you do commonly, even in commands. But port security is all about MAC addresses. You'll see that. And we're going to use a command where they ask you to actually enter the secure MAC address that you're creating. And you're going to have to enter it the way iOS help tells you to, not exactly the way you want to. The point of this is you can see them expressed this way in documents, books, study guides, anything else. And all of these are expressing the same address. Case also does not matter. I didn't want to burn your retinas by putting up 4 more sets here, but if all of these were in capital letters, that would be fine too. Now, a couple of you are thinking, I don't know anything about hex and I don't know what that A is about. Well, we're going to take care of that right now. And I've been there. At first, it looks like an unknown language. With a little bit of practice here and there, you're going to be using hex as easy as 1, 2, 3. Because the first time you look at hex, your first response might be along the lines of OMG. Because there must be something horribly complicated about a numeric system that uses letters instead of numbers, because that suggests algebra, which suggests more complicated algebra, which suggests something you don't want to do. But you're going to see how easy this is. My apologies to algebra lovers. I like algebra too. But there is nothing complicated about this. First, I'm going to compare it a bit, though, to the numeric system that we use every day, decimal. It uses units of 10. And this is certainly not something you think about because we do it so often. But if you have, let's say, a 3-digit decimal value, and if you read it from right to left, the number indicates how many units of 1 and 10 and 100 there are. And again, this is a lot more thought than we usually put into decimal, but it's going to help you with hex. For example, the value 289 breaks down like this in decimal. And you're just going from right to left. You got 9 units of 1. Then you're going to move up to 10, 10 times 1. 8 units of 10. And then for the next number up, the units are 100. You got 2 of those. So it's 289. We don't look at the decimal 289 and say, okay, that's 2 units of 100, 8 units of 10, 9 units of 1, because we use it so often. And it doesn't necessarily stop there, because what would, if this decimal were 7289, what would the 7 represent? Of course, 7 units of 1000, which would be 10 times 100. Well, hex values are really read much the same way, especially when you're learning them, but we're dealing with units of 16. So if I gave you a number 289 but said this is a hex value, this is the way it breaks down. It still breaks down as 9 units of 1 starting from right to left, but then you're dealing with units of 16 because again hex is base 16. We're working with units of 16 here. So you've got 8 units of 16. The next number up, that 2, is going to be 16 times 16, 256. So that is exactly what we're looking at with hex. And again, just takes a little getting used to, and the key is practice. More on that in a moment. But hex uses units of 16, so the first thought you have when you hear that is, well, how can we represent a value of 10, 11, 12, 13, 14, or 15, with a single character? Because that's what we're doing this for. Well, we do so with letters, and we use the first 6 letters of the alphabet for these 6 mappings. A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, F equals 15. That's as high as we go. And the case does not matter. Uppercase, lowercase a, it's still equaling 10. The key to success with hex is not just watching what I've put here and then say, okay, I got it, and then never practicing again. Because boy, did it ever come up on me once when I didn't think it was coming up. Just a quick aside, I had not looked at hex in a long, long time the day I took my CCIE lab exam. And the very first thing I had to do that was getting me started, I mean, I could not do the rest of the lab without doing this one simple little exercise, and it involved hex characters. It is amazing what you can start remembering from high school or college when you, years and decades later, when you really have to. So I want to spare you that on the CCNA exam, because you're going to nail every hex conversion question they give you. And here's why. Because the key to success with hex is just practicing. Hex to decimal, from decimal to hex. And when I say here are a few values for you, I tell you what I'm going to do. I'm going to create another video here, and we're going to do some walkthroughs with some hex conversions. And then after you're done with those, you can make up your own conversion practice questions. The thing is, and this is so important because it's a good study habit, little dad lecture here, a little study habit thing, because I've fallen into this trap before as well. When you start studying something, especially something new, you get into what I call He-Man mode. You can call it whatever you want. And it's like, I'm going to study 16 hours a day and never sleep. And you know what happens. You burn out at that pace. And what you really want to do is just make the best of the time you have. And especially with something like this, because look, everybody's got 5 or 10 minutes here or there, okay? I don't care how busy your job is. I don't care how busy your life is. You've always got 5 or 10 minutes where you can take a little bit of a breather. You know what? You just take a piece of paper, you take a pencil, you just, without even thinking, write out 5 hex values and say, okay, if I needed to convert these to decimal, how would I do it and what would the answer be? Or just write down 5 decimal values and say, okay, what would that be in hex? Shoot, pull them off a menu, pull them off a coffee shop menu. I don't care where you get the decimals from. Just get them from somewhere and do the hex conversion right there where you are. And the little bit of extra work there, 5 or 10 minutes here and there, pays huge dividends on exam day, because by that time it is second nature to you. And that's exactly what you want, because when you walk into that exam room, when you're getting your CCENT or your CCNA, your attitude should be, I already know all this. I am already at this level. I'm just here to prove it to you. We're going to have a conversation via this exam, and I'm going to prove to you that I'm already a CCENT, that I'm already a CCNA. I'm just here to make it official. Having said that, let's march on. The next video, again, will have some hex and decimal conversion walkthroughs for you. So grab a little something to write with and go along with me on that. And then the video after that, we're going to start with some basic switch configurations. We're going to write our first Cisco switch commands, and we're going to work with those virtual LANs as well. I'll see you there.